Bismillah Rahman Rahim. Dear cadets, I am Raja Shakil, and on today we are going to learn about the Kirchoff's laws, two laws. One is Kirchoff's voltage law, and the other is Kirchoff's current law. So we are having two laws, voltage law and current law. So our topic is Kirchoff's laws or rules. We may say them as laws as well as the rules. So we are having two laws or rules. One is voltage law, two laws or rules. One is Kirchoff's voltage law, and the other is Kirchoff's current law. Both are having bit difference, but both are related to each other. How they are related? That one thing is that clearly that both laws have been presented by the same physicist as well as at the same time, and along with this, both laws are describing, one law is describing the voltage while the other law is describing the current. And actually a system in which current is flowing, we are associated with two things, one is voltage and the other is current. So both things are being covered, so these laws are related to each other. Anyhow, we'll be looking into the Kirchoff's voltage law, and we'll try to understand that what is this thing. So at first, we'll be looking into the voltage law, Kirchoff's voltage law. As far as this law is concerned, we have tried to understand that what has been described in it. For this purpose, we have to draw certain diagrams, and then we'll be understanding these concepts. So let us consider that we are having a certain circuit. Let us consider this is a circuit. And in this circuit, we are connecting a battery. So let us consider that actually we are going to make a complete circuit with different loops. Here is the resistance. And so on. But before making any connection to any other loop, we have to, firstly, we have to try to understand this circuit, and then we'll be looking into the others. And let's consider, we suppose two batteries are attached here. From here, you can easily understand that one battery which is having the one side is smaller and the other is longer, then it means that the smaller size is actually negative side while the other side is the positive side. So smaller one, the smaller in length, is representing the negative, while the longer one is representing the positive side. For example, this side is smaller as compared to the other. So this is negative, while the upper side is positive because it is having more length as compared to the other side. This is only representation, but in the battery it is not the fact. बैटरी के अंदर ये काम नहीं होता कि एक साइड स्मॉल है और दूसरी लार्ज है. This is happening only and only for the diagram representation. We have made the representation, symbolic representations. These are only symbols. Let us consider the name of this battery is epsilon 1, while the other battery is having the voltage or EMF of epsilon 2. And you can understand that the right side of this battery is negative because it is smaller side, while the left side is positive because it is the lengthy side. So I've already told you that these are realistically these are not smaller or lengthy, but only for the representation because we have to represent. Okay, then let us consider that this is a resistance, first resistance, this is R1 resistance, while the other resistance is R2. And let us consider that the voltage across the resistance R1 is V1, capital V1, and the voltage means potential difference across R2 is V2. So you can see from here that these two batteries, battery 1 and battery 2, these two batteries, epsilon 1 and epsilon 2, are having certain amount of voltage which is being provided to the whole of this circuit. So what is that voltage? You can see from here that both batteries are trying in such a way that both are trying to cancel the effect of each other. How? You can see from here, from the diagram it is clear that you know that usually we are concerned with the conventional current. Conventional current is the current which flows from positive toward the negative. So from the battery 1, this is battery 1, and this battery 1 is trying to make the flow of the current in such a direction that the positive, because upper side is positive, so from the positive it is moving it is trying to move the current in this direction, upward direction. So this battery is trying to move the current in the upward direction. Upward direction means from here, if it is going upward, then it is going to this direction and so on. So as a result, the battery 1 is practically, it is trying to move the current in the clockwise direction. Okay, but for the battery 2, for the second battery, what is happening for the second battery? That second battery is trying in such a way that since its positive side is along the left side, so it is trying to move the current towards the left side. Therefore, this current will be moving in opposite direction if only second battery is connected. So both of these batteries are trying to produce the currents in opposite directions, because epsilon 1 means first battery is trying to move the current in the clockwise direction, while the second battery is trying to move the current in the anti-clockwise direction. So here is the main problem. So what will happen? Overall, what will happen? Let's see that, for example, epsilon 1 means battery 1 has the voltage of 10 volts, while epsilon 2 epsilon 2 is having the voltage of 8 volts, then actually, since the battery 1 is more powerful as compared to the battery 2, because battery 2 is having only 8 volts while the battery 1 is having 10 volts. Therefore, what will happen, that the battery 1 is more powerful as compared to the battery 2, and hence overall result will be such that the battery 1 will be having more capacity to move the current, but the battery 2 is trying to waste its energy. So overall result will be that 10 volts minus 8 volts. Why minus? Because both are opposing each other. Therefore 10 minus 8 will be 2 volt. So the overall current will be moving due to this 2 volt difference, 2 volt difference. Okay, anyhow, I'm going very deep. I think that there is no need to go too much deep. Anyhow, let's see. You must try to understand that both of these batteries are opposing each other, so their net voltage will be in such a way that this is, for example, epsilon 1 is trying to move the current in positive direction, means clockwise. So you will consider that how it is happening, that for example you are considering the current in clockwise direction. It is your own, on your own, that either you consider the current in the clockwise direction or anti-clockwise direction, because currently we don't know that what is happening, that which battery is more powerful and which is not powerful. We don't know. Actually, we were making the supposition of 10 volts and 8 volts, but usually in numerical problems we are not told about this. In that situation, we may consider either in the clockwise direction or anti-clockwise direction. It depends on yourself. Anyhow, for example, if we are considering the current flowing in the clockwise direction, then what will happen, that this is epsilon 1 battery is actually trying to move the current in the clockwise direction. Therefore epsilon 1, and then the other is the next thing is epsilon 2, the battery 2 is going to be added into this situation, but battery 2 is actually opposing. So this battery 2 will be minus, plus into minus. Minus means it is opposing, while the all of the voltages of the resistances, means V1, V2, V3 and so on, these will always be considered to be the negative voltages. These will be negative voltages. So plus into minus V1 and plus into minus V2. According to Kirchoff's law, according to Kirchoff's statement, the sum of all of these voltage changes must be equal to 0. Why? Because the total net voltage provided by the batteries is going to be consumed by the resistances. Therefore, whole of the energy is being consumed which is provided by the batteries, and net result is equal to 0. And you may also write this equation to be as epsilon 1 plus negative of epsilon 2 minus V1 minus V2. These are not small V1 and V2, these are capital V1 and V2. So you have got this thing, or you may also write it as epsilon 1 plus into minus epsilon of 2 is equal to V1 plus V2, because they are going toward the right hand side, their signs have been changed. Okay, now you know that this epsilon 1 and epsilon 2 is the sum of all voltage provided. all EMFs provided to the circuit. So this is the sum of all EMFs, means you may write it as summation this is the capital sigma. Capital sigma is the symbol of summation. So summation of all epsilon is equal to, on the right hand side it is V1 plus V2, means all voltages. So summation of V, this is, you may also write it as summation epsilon is equal to summation V is equal to actually IR, and R is actually R1 plus R2. Current is same. Why current is same? Because the number of charges passing from every point are same, because this is a closed circuit, and so all of the charges will be similar to each other. So you may write it as this thing. Anyhow, this is the, you may also write it as summation of epsilon is equal to summation of I RE. RE stands for the equivalent. You may also write it as this thing, or you may also write only simply IR. There is no issue in that. I hope you have got the understanding of this concept. Now, dear students, do you have any type of question? You may ask, please. Tala Afzal, do you have any question? Usman Awan, Taha Safi?
No, sir. No, sir.
Okay. Okay, I'll be proceeding ahead. Now, let us consider more simple case. We are having a single battery, a system of the single battery. And this single battery is having only one resistance in it. In the previous case, we had studied two resistances and two batteries. But in this case, we are studying one resistance with one battery. Okay, Usman Awan. Usman Awan,
Yes,
are you
sir.
here?
Yes, yes,
Okay,
sir.
can you tell me that which is the positive terminal of the battery and which is the negative terminal of the battery?
सर जो ऊपर है वो पॉजिटिव है, जो नीचे है सर वो नेगेटिव है. बड़ी डैश जो है वो पॉजिटिव है और छोटी सा नेगेटिव.
Great, well done, excellent. Okay, so this is upper side is positive while the lower side is negative. And let us assume the name of the battery to be epsilon. Epsilon is actually the EMF of the battery. So it has the EMF of epsilon, while the other, on the other side, this and other thing has been connected. So Tala Afzal, can you tell me that what other thing has been connected in this circuit other than battery? What is the other thing? Salah Afzal. I think that he's not present. Salah Afzal, are you here? I think he's sleeping. Okay, Taha Safi.
No,
Can
sir.
you tell me? Okay, so tell me that what other device has been connected in this circuit other than battery?
Tell me again, sir, please.
I am saying that this is the circuit. This is whole of this is circuit. Okay, can you see this? So
Yes, sir.
it is having a battery on the left side. This is a battery.
Yes, sir.
Usman Awan had told me that this is a battery and it has a positive terminal and a negative terminal. What other thing has been connected in this circuit other than battery? इस सर्किट में बैटरी के अलावा और कौन सी चीज कनेक्ट की गई है?
वायर
वायर तो है ही, वो तो वायर से हाँ जी, यस रेजिस्टेंस। तो तलहा आपको ये रेजिस्टेंस नहीं नजर आ रही थी राइट साइड पे जो है? Anyhow, this is resistance. So it has two things. One is battery and the other is resistance. This is the simplest form of any circuit. Anyhow, according to Kirchoff's rule, we have to see that the sum of the voltages must be zero. Anyhow, so this resistance has a voltage which may be represented by capital V. So let's see that we have already said that sum of the EMFs must be equal to that the sum of EMFs and must be equal to it must be equal to the sum of the potential differences of the resistances. This is the Kirchoff's rule. Or you may say it to be as, what is the sum of EMFs? Here is only one EMF. So epsilon is equal to, next is sum of the potential differences of all the resistance. What is the sum of the potential difference? Only one potential difference is found here, and that is V. So epsilon is equal to V. Or you may also write it as epsilon minus V is equal to 0. Now let's see the next. Anyhow, this was the basic concept of this, of the Kirchoff's rule. Now we'll be proceeding towards the Kirchoff's voltage law has been studied, but now we will be moving toward the Kirchoff's circuit law. Sorry, I'm very sorry. This is Kirchoff's current law. Current law. So if we are trying to look into the current law, what is about that? So let's see here. We'll be trying to get the concept of the current law. So if we suppose that there are many wires which are meeting at certain point, for example, these wires are meeting at this point, are connected to this point. All of these wires have been connected to this point. Let us suppose that every wire is having a certain amount of current. For example, this wire is first wire, wire 1. This is wire 2, and wire 3, wire 4, and wire 5. And let us consider that from wire 1, the current is coming toward it, toward the terminal, this point, middle point, where all of the wires have been connected. So a certain amount of current is I1 is coming toward this place. I1. While the second wire is having a current of I2 coming toward this point. For example, the name of this point is C. C for center or origin. So let us consider the wire 3 is also having a current which is entering into this system. This is I3. While for I4, for the fourth wire, I4 current is leaving the system. This is leaving. I4 current is leaving. And for I5, fifth current is also leaving. I have made the directions out here. Arrows are indicating the directions of the currents. So the total current entering this point is equal to I1 plus I2 plus I3. So total current entering will be equal to I1, because I1 is entering this point, I2 and I3. All of these currents are entering in this point. This point is called as the junction. Now, what is the total leaving? Total current leaving this point. Means which is going away from this point. Leaving is equal to I5. I5 is leaving and I4 is leaving. So I4 plus I5. These two currents are leaving, therefore this total current leaving this system is I4 plus I5. According to Kirchoff's law, so according to Kirchoff's law, total current entering is equal to total current leaving. यानी जितना करंट उसमें एंटर हो रहा है उतना ही लीव करेगा, उससे ज्यादा तो नहीं कर सकता, यहाँ उससे कम कर सकता है, क्योंकि करंट खुद से जाया तो नहीं हो जाएगा. It will not be destroyed or it will not be automatically produced. So for example, 100 charges are entering in this point, then 100 will be leaving. This is the Kirchoff's law, or Kirchoff's rule for the current law. You have got it. Okay, so this was the main theme. Now, yes, the time is over. Yes, I know. Okay. I hope you have got any. Let me write another equation. So leaving and entering must be same. It means that actually entering was I1 plus I2 plus I3. It must be equal to the leaving. Leaving is I4 plus I5. Anyway, it depends on the situation that how many wires have been connected and what are their names. But you have to remember that the total current entering must be equal to the total current leaving the system. This is the rule. Anyhow, the time is over. Dear cadets, if you want to ask anything, you may ask. Please don't hesitate. Any person willing to ask any question relevant to this topic, you may ask, please. Taha, Talha, Usman.
Yes, sir.
Any question in your mind? Any conceptual question in your mind?
No, sir.
Okay. Any of all of the cadets who are present at the moment, I want to appreciate all of those because they are trying their best. Very well done and highly
Thank you,
appreciable.
sir.
Very, very thanks, bacho. Thank you very much and Allah Hafiz.
Thank you, sir. Allah Hafiz.
Allah Hafiz, sir. Ji, Allah Hafiz.